Hey guys, alright, so complex redox, the thing we've all been waiting for in terms of the videos. As we've seen in class, these are not as complicated as they actually first appear. They're kind of like puzzles and they're actually kind of fun. Just to remind us a little bit about what complex redox are. We have these substances that when they're introduced are already in an acidic or basic solution, they act a little differently than we're used to seeing. For example, a permanganate in an acidic solution breaks down into a manganese 2 ion and water. So we have a bunch of these. Remember, you don't have to memorize any of these. What I need you to be able to do is be able to write out your half reactions and then go from there. And here's all our list of them. So let's go through, look at our rules, and practice a couple of these. Okay. So an acidic solution, and we saw this one in class, but I'm going to go ahead and do it again. Let's say we're looking at copper metal added to dilute nitric acid. First off, notice that it says acid here. So we know this is in an acidic solution. Okay, on the test, I'll give you something more like this, or the quiz, I should say, not test. We're quizzing over this stuff. And I'll say it's an acidic solution. So you won't have a word problem, but you'll have the equation at bare minimum like this. Okay, so our first step here is to write our half reactions. And I apologize, my smartboard seems to be moving a little bit slow right now. We write our half reactions, so in this case we find what matches on each side of the arrow. So here it's going to be the copper, and then it's going to be the nitrate and NO. So our two half reactions are going to be copper going to our copper ion, NO3 going to NO. So that's our first step, it's just writing our half reactions. The second step, which is true for all of these, is to balance all elements, but we will not be balancing our oxygens or our hydrogens yet. So in this case, we would look at copper and copper, which are perfectly balanced, so we leave them alone, and then the nitrogen and nitrogen, which is also perfectly balanced, so we leave it alone. From there, we balance our oxygens. Now, in an acidic solution, remember that a solution has water present. In an acidic solution, we also have hydrogen ions present. So that's what we're using here. So in this case, copper and copper, we don't have any oxygen to have to balance. So our half reaction is going to remain the same as Cu going to Cu plus 2. However, with our NO3, our nitrate ion going to NO, we have oxygens here. I have 3 oxygens here and 1 oxygen here, which means I need 2 more oxygens on my product side. So what I'm going to do is add 2 waters. And the 2 waters gives us our 2 oxygens. The problem is, it also gives us 4 hydrogens. So again, remember in acidic solution we have water and hydrogen ions present. So now what we're going to do, our next step, is balance the hydrogens we just added with hydrogen ions on the other side. So again, copper half reaction staying the same, copper forming copper plus 2, and then nitrate forming NO plus water and 4 hydrogen ions back on our reactant side. Okay? From there, this is kind of our point where we start getting to something a little more familiar, which is balancing our electrons. So in this case, we have, with this, instead of looking at individual elements, we'll look at the whole reaction and we'll look on each side of the reaction. So over here, 4 hydrogen ions is a plus 4. And then we have nitrate, which is a negative 1. Over here, we have 0 and 0. So we're going from an overall charge of plus 3 going to 0. Well, what happened there? We obviously gained 3 electrons. So we can rewrite that half reaction as 3 electrons plus 4 hydrogen ions plus NO3 forming NO plus 2 H2O. Okay, we can do the same thing with the copper. We're going from 0, because remember all elements are 0, to plus 2, which means we have lost 2 electrons. So we'd have our electrons on our product side. So Cu forming, or sorry, Cu, sorry, not CO, Cu 0 forming Cu plus 2 electrons. Our next step is to equal our electrons, which means we multiply to get our electrons equal. We have 2 electrons here, 3 electrons here, which means we multiply the top one by 3 to get it to equal 6 electrons. And we multiply our bottom one by 2 to be able to get it to equal 6 electrons. So what we end up with is 3 coppers forming 3 copper ions Whoops, let's rewrite that. 3 copper ions. There we go. Plus 6 electrons. 6 electrons plus 8 hydrogens plus 2 nitrates, forming 2 NOs and 4 waters. Our last step is to combine and simplify. And remember, I kind of do this step together, or do it all combined. Get rid of that over there. Sorry. Our electrons we know cancel out. We don't have any hydrogen or water to cancel out. So what we end up with as our final reaction is 3 coppers plus 8 hydrogen plus 2 nitrates, forming 3 coppers plus 2 NOs plus 4 H2Os. Okay, so let's look at another one a little bit quicker. We have our full reaction. Rewrite our half reaction, so ClO3 forming Cl minus. Again, we're finding what 2 things belong, so chlorine belongs to chlorine. And then we have SO2 forming SO4. We balance our oxygens, so we have 3 oxygens here, 0 over here, so I'm going to add 3 waters on this side. Here we have 2 oxygens, 4 oxygens. I'm going to add 2 waters on this side. I'm then going to balance my hydrogens. By adding the 3 waters, I now need 6 hydrogen ions over here. By adding the 2 waters, I need 4 hydrogen ions over here. So at this point in time, we're good to go. Let's balance our electrons. So if we're looking at here, at this top reaction, we have a positive 6 from our 6 hydrogen ions, a negative 1 from our chlorate, which gives us a total, if we're to put this together, of a positive 5. We have a negative 1 from the chlorine and a 0 from the water, so a total of negative 1. So going from a plus 5 to a negative 1, what did we do? Okay, well, we gained a total 6 electrons, 6 negative charges over there to go from positive 5 to negative 1. Think of a number line. If you're at 5 going to negative 1, how many did you pass through? And at that point, 6, so 6 electrons. Down here, same thing. We have 0 on this side of the equation because SO2 and H2O are neutral. Sulfate is negative 2, and we have a positive 4 from our hydrogen ions, so that gives us a total of positive 2. So if we're going from 0 to positive 2, it means we lost 2 electrons. So we're going to add 2 electrons here. Okay, 6 to 2, we simply multiply the bottom one by 3 to get what we want. Okay, so we end up with 6H2O plus 3SO2 forming 3SO4. I'm going to get rid of this positive 2 that's right here, plus 12 hydrogen ions plus 6 electrons. So we can kind of ignore this middle one right here because it's been rewritten for us here. Okay, so now what we can do is cancel out and add together. So we know our electrons are going to cancel. That was the whole purpose of what we just did, is to make them cancel. Now check this out. We have 6 hydrogen ions and 12 hydrogen ions. So we know we can cancel out 6, and 12 is going to drop down to 6. Also our waters, 3 waters, 6 waters. So 3 cancels out. And our 6 is going to drop down to 3. So now we can add everything together with what's left over. Well, I have 3 waters left on this side, which is coming from here. I have 1 chlorate ion, which is coming from up here. 3 SO2s, whoops, try that again. 3 SO2s, which is right here, forming 1 chlorine, which is here, or chloride I should say. 1 SO4, which is right here, or sorry, 3 SO4s, there we go. Plus, finally, our 4 hydrogen ions. Okay, so that's it for acidic. Let's look at basic real quick. It really works the exact same way. The only difference is that in a basic solution, we don't have hydrogen ions. We have to use hydroxide ions to cancel out the hydrogen ions we balance with. So let's kind of look at what that looks like. Again, we write our half reaction. So Cr plus 3 forming a chromate ion. CrO4 negative 2. And we have our ClO3 chlorate forming our chlorine. So again, we're just finding what matches. We're still going to balance just like we have, which means looking at elements first. They're taken care of. Then we look at our oxygens. Well, we have 4 oxygens over here, which means we need 4 waters over here to balance that out. 3 oxygens here. We need 3 waters over here. So we're still going to balance with our hydrogens. So I need 8 hydrogens over here, and I need 6 hydrogens over here. The problem is we don't actually have hydrogen ions. So what we actually have to do here is cancel them out by using hydroxide. So we add the same amount of hydrogen ions as we do hydroxide ions. So 8 hydrogen ions plus 8 hydroxide ions. But what I do to one side of the equation, I have to do to the other. It's just like algebra. Okay, 6 hydrogen ions here. I add 6 hydroxides to this side of the equation, and I add it over here as well. So that kind of gives us that. Now let's kind of simplify this a little bit because it starts to get messy real quick and in a hurry if we don't. I'm going to move this down real quick. Okay, the first thing I would do is simplify my individual half reactions, which means 8 hydrogen ions plus 8 hydroxide gives us 8 waters. Well, if I look, 4 waters over here, 8 waters over here, the 4 are going to cancel out on this side, and I'm going to have 4 left on my product side. Okay, same thing down here with our other half reaction. 6H2O and 6 hydroxides and 6 hydrogens will form 6H2O. Okay, well I have 3H2O over here. That goes away, and I'm left with 3H2O. Okay, I'm going to real quickly rewrite these so that we can see them a little bit better. So I have 8 hydroxides plus a chromium ion, a +3, forming chromate, plus 4 waters. Okay, I also have 3 waters plus a chlorate ion, forming chlorine, plus 6 hydroxides. Okay, so now we get to the point where we're familiar. Now we balance our charges. So we have 8 hydroxides here, which is -8, plus a +3. That means there's a total of -5 on this side of the equation. -2 for our chromate and 0 for water, so a total of -2. So we're going from -5 to -2, which means we lost 3 electrons. Same thing down here. We have 0 and -1, okay, and that gives us a total of -1 over here. We have -1 and -6. This gives us a total of -7. Well, -1 to -7 means we gained 6 electrons, so we have 6 electrons over here. So again, we need our electrons to balance, so 3 here, 6 here. We multiply this whole top one by 2, so I'm going to rewrite it actually underneath here. So we end up with 16 hydroxides plus 2 chromium ions, forming 2 chromate ions, plus 8 waters, and 6 electrons. Okay, so our electrons cancel. Now we add up and cancel everything out. Our waters cancel and leave 5 H2O over here. Our hydroxide cancel. We have 6 here and 16 here, so that leaves 10 hydroxides over here. Okay, and now all we have to do is add down. So we end up with 10 hydroxides plus 2 chromium ions plus a chlorate ion, forming a chlorine ion plus 2 chromate ions, and write this down here, 5H2O. Okay, so that's basic. So really same thing as our acidic solutions, just with the hydroxide caveat added in. All right, guys, that's it.